Hello, and welcome to Backer Breaks It Down. In this episode, we are still working with quadratic functions, but now we're going to write a quadratic function in its factored form. Okay. So one way of writing a quadratic function is to write it in its factored form, also known as its intercept form. An intercept form looks like this: y equals a times the quantity of x minus p times the quantity of x minus q. Now the x-intercepts, that's what p and q are representing, okay? So like in number 5, one of my x-intercepts is -1 and the other one is 3, so p and q are -1 and 3. And then xy is one other point on the graph, okay? So you're going to substitute these 4 values into your factored form. The only thing that you won't know is a. That's okay, because after you substitute these values in, you're going to solve this for a. And then you're going to go and you're going to write your equation using only a, p, and q. So what that means is that x and y become variables again. So let's see this in action. So as I've already mentioned, our two x-intercepts are the p's and q's. So p is -1 and q is 3. And then this other point, the y-intercept that they've given us, that's our x and y. So x is 0 and y is -6. So I'm going to substitute those into my factored form. So I'm going to have y, which is -6, is equal to a, don't know, times the quantity of x minus p. Well, x is 0, and then I'm minusing p. P is -1. So if I minus -1, that's just going to become +1. And then I have times the quantity of x minus q. X is still 0, and q is 3. So I'm making those substitutions. Done. Now I'm ready to solve for a. So what I should really do first is like simplify this. Like, what is 0 plus 1 times 0 minus 3? So if I do that math, I'm getting -3. So I have -6 equals a times -3. And then if I divide both sides by -3, I get that a is equal to +2. And then that's my solve for a step. Now I'm ready to write the equation using a, p, and q, meaning x and y are variables once again. So I'm going to have y equals a is 2. Then I have x minus p, so x minus -1. It's the same thing as x plus 1. And then x minus q would be x minus 3. And there's my quadratic function. So it's a pretty easy thing to do. Let's try it one more time. So this time, don't have the graph. They're giving me words. They're like the x-intercepts are -1 and +2, and the -216 is on the graph. So once again, those x-intercepts are your p's and q's. And then this one other point is your xy. You're going to substitute those in. So we're going to have y, which is 16, is equal to a times the quantity of x, which is -2, minus p is -1 again, so that's going to be +1. And then the quantity x minus q, so x is still -2, q is +2. So I substituted all of my stuff in. Now I'm ready to simplify and solve for a. So if I do this math here of -2 plus 1, that's -1, and then -2 minus 2 is -4. So that multiplied together is +4. And then if I divide, I get that a is equal to 4. And then the last thing I do is I write my function. So my function will be y equals a is +4, and then I'm going to have x minus p. P was -1, so that becomes x plus 1, and then x minus q. Q is 2, and so there's my function. So one way of writing a quadratic function is in factored form. This makes sense if you have the x-intercepts. Then factored form makes perfect sense. Simply substitute your x-intercepts and the x and y values of one other point into your factored form. Solve for a, write your function, and that's how Backer breaks it down.